algebra. So these are, so the corresponding two-dimensional CFT has the so-called Wn symmetry. So this is a nonlinear algebra, unlike the SLNR algebra. This is the generalization of the Brown-Hainaut result that so Brown and Hainaut showed that any theory of gravity in ADS3 has an asymptotic Virasoro algebra, which is generated by this stress tensor. But now you have all these, and together they generate a Wn algebra, which was shown by Hainaut and Ray, and also by the Campoglione et al., the Max Planck Potsdam group. So you have this, and there's a generalization for the HS lambda Vasiliev theory. You get these 2D CFTs with so-called W infinity symmetry. The W infinity symmetry is labeled by this parameter lambda, which appears in the HS lambda. And you can construct, so there are interacting, unlike in higher dimensions, there are interacting CFTs with these symmetries. And one can show that the Vasiliev theories capture some of the aspects of these 2D CFTs in a holographic way. And so, so this, as I said, it's a very, right at the beginning I mentioned these are more tractable examples of ADS CFT. You can make many precise checks. You can, for instance, match the partition function, the generating function of the states here, to those of the corresponding states in the CFT. These are exactly solvable CFTs. You can match correlation functions computed, the gravity on the Vasiliev side to correlation functions in the CFT, properties of black holes, the entropy of black holes, these novel black holes that I mentioned. You can, with higher spin charges, you can look at their properties from the point of view of the CFT. And so that you can make a number of non-trivial checks. So this is an arena where this holography is very concrete. It doesn't require much any string theory. The CFTs are CFTs that people have studied in detail in the 80s. In fact, the corresponding family is a generalization of the ones that describe the Ising model and the so-called minimal model CFTs, if you've heard of those. And these dual Vasiliev theories, again, as I said, they are constructed independent of string theory. They by Vasiliev, and I sketched their construction for you. They are maybe unfamiliar, but they're not. They are reasonably tractable, and so you have this sort of duality between these theories of gravity and these CFTs. So it's a good laboratory to understand the ADS CFT better. But anyway, if you're again interested in reading about that, please consult the reviews. But let me just stop over here. Thanks.
Thank you very much. I would like to welcome one or two questions.
In 2 dimensions, SF MR is related to the total field theory. Is there something similar in 3 dimensions?
So this Wn, the total field theories have this Wn sort of symmetry, and in fact, but they are non-unitary CFTs. So there is some sense in which they are related to the SLNR Vasiliev theory. They have the same kind of representations. So in this duality, the 3D Vasiliev theories are dual to the 2D sort of Toda-like theories. But there are unitary CFTs which have this Wn symmetry as well, which are for the C less than n minus 1. So they are like the analog of the minimal models. Toda is analog of Liouville theory, but you have the analog of minimal models for Wn. And those are unitary theories which are actually dual to Vasiliev theories as well. So there are unitary CFTs for which this duality holds.
Other questions?
So is the gauge group actually SLN modded center or SLN?
Yeah, to be more accurate, it is SLN modded center. And if you're in the Euclidean theory, it's SLNC is the gauge group, and so its center is actually Zn. So that's what allows for many interesting these conical defect-like solutions, because the holonomy can be an element of the center, which is non-trivial. It belongs to Zn, so there are many possibilities. Yeah.
Other questions from students?